All right, thanks everybody. My name is Paul, and I'm going to talk a little bit about this loading screen. Buffering. Okay, hopefully only that one slide does that. So my talk is about a type-safe API layer. My name is Paul. This is a picture of me dancing alone in a conference room. If you don't know me, a few little facts about me. I'm currently the engineering team lead at a company called Lyssna, which is a Melbourne-based research platform. This is my 10th year in Wellington. From Auckland originally, but my wife and I moved here 10 years ago, and we really love the lifestyle here. And I'm currently learning to knit. So the only thing that has more tangle than my spaghetti code is this scarf that I made just days ago. So this is my latest skill that I'm taking up. So now that we know each other, I will talk a little bit about Lyssna, the company I work for. It's a user research platform, so we do moderated and unmoderated research, surveys, interviews, things like that. The tech stack is a majestic Rails monolith, has a React front end, kind of standard software as a service product, but a very, very fun company to work for, and that's important because we are hiring. So have a look on the website. I won't take up too much time in this talk talking about it, but it is fantastic, and I'm happy to talk to you more about it afterwards if you want to know more. The absolute best perk is it's Australian salaries without too many Australians. So come and see me after if you want an intermediate or senior developer job. So what I want to talk about today is a little bit about APIs. So I want to talk about some options for keeping your API surface consistent across your backend and your front end. I want to talk about the specific way that we did that at Lyssna and some of the trade-offs that we had when we were implementing it. And I want to wrap it up with some kind of general principles about things we might learn from this kind of experience, even if you're not doing this exact exercise yourself, because I understand it's a very niche topic perhaps. So what I'm thinking about here is the kind of app that I work on is a single repo that has a Rails app in it and it has a JavaScript app in it, essentially two separate apps. Obviously, traditionally, these Rails apps would have been server rendered, you'd schedule the HTML and you'd send it down the wire. But these days, a common pattern for doing that is obviously having your Rails app as more of an API layer and having a totally separate JavaScript app that's statically hosted and deployed independently. And the way they communicate is these arrows between the two really is a lot of data going back and forth across the wire. Obviously, that's not the only way you can build websites. There are, like I said, server-rendered Rails, and the pendulum is kind of swinging back in that direction. There's tools now like Turbo and Phoenix Live View and Stimulus and all that good stuff. But I still think that the SPA model is compelling, and I think there's a few reasons for that. I think the developer experience of working with React is really solid. The way you can compose a React app out of components and reuse different bits, and the tooling around it is really, really nice to use. I think if you're working on an app that needs a lot of interactivity, has a lot of lots of things going on in the UI, it's much easier to do that kind of work in pure JavaScript. Obviously, there's a lot of packages and support for doing React and doing JavaScript on the browser. And latency is a real killer for back-end only apps. So if you happen to live near the server, then everything works great. But they can fall down in environments, and particularly offline first doesn't work very well if you really rely on serving everything from your back-end. So I think there's still room in the world for these apps, and especially if you work at a company that has a legacy app, you're probably going to be working on something like this. We have a Rails app that maybe started off being a server-rendered app and is gradually moving more and more to being just like an API for your separate front end. And so what I want to talk today about is this bit in the middle, this tangle, and how you can tame that a little bit. And so what I'm thinking about is you have some UI in your app, in your JavaScript, you do some action and you call an API, and how does your front end know what's going to happen when you hit that button or what it's going to get back from the server? Traditionally, you just have no information about that, right? At build time, you just don't know what's going to happen. And the way the way that people have solved this in the legacy code bases I've worked on is you manually specify what types. So this is some TypeScript code. We're doing a post using Axios, which is like quite a common URL or like a HTTP call library. And you just tell it what type the response is going to have. And that type is probably specified in the same document. Someone wrote it by hand. Probably at some point it reflected like the reality of that API, may or may not now. But it's a little bit brittle, a little bit error prone. And when the types don't match on the server and the client, you often just run into runtime issues. This is obviously like something you'd see in your dev tools, hopefully not a customer seeing this, but you can run into problems if the data is not there that you expect, or it's a different type than you thought it was. And it's hard to tell at compile time or at code time what's going to go wrong. You don't really know until you run into it in real life. So the aim is to keep the front end and the back end in sync. And I'm not talking specifically here about like having two separate teams in your company. Like if you work for a small company like me, you're probably doing all of this yourself. So the meme looks a bit more like this maybe, where I'm a full stack developer, I'm building the whole app myself. It's not necessarily about communicating with other people, but it's just more about keeping the different parts of your code, knowing what's going on, and having a single source of truth. That API layer is really the shared communication layer between the two parts of your code. And it's useful to have that barrier to be able to compartmentalize parts of your code and not to have to think about the whole thing all at once. So there's heaps of benefits of having just one place be the source of truth for how your API works. Less runtime errors, hopefully, less likely to drift out of sync over time. I shouldn't have made these animate because I can't remember what I wrote. Now I have to read it at the same time you're reading it. Having this here kind of doubles as like a documentation for developers in the sense that you can look at one place and know this is the truth of what my API contains and how it works. And obviously just like not having to duplicate the data twice means less work for you to do, which is great. And I think an underrated benefit is being able to work on the front end and know that that API is kind of like the event horizon past which you don't have to understand, even if you will eventually build the back-end part yourself. Right now you don't have to think about that. The API has everything you need to know to be able to work with it, and everything else is like a black box essentially. So when you have these two worlds like this and you want to join them together, obviously either one of them could be your starting point, and there's lots of good options for both. This is a gem called typescript serializers. This lets you take your active record serializers or OJ serializers or whatever and make that the source of truth for your API definition. So when you're defining your serializer, you annotate it with a bit more information about the types of things, and you can use that to generate TypeScript types directly and use them in TypeScript. So I haven't used this, looks cool, it's a great idea. This is like the opposite of that, where you start with TypeScript types, and then you could use that to generate an OpenAPI spec. Same idea, you just TypeScript is the source of truth in this case, and you generate a definition and then figure out how to use that later. Also haven't used this, it's a good idea, I like it. But my idea is, rather than having either of them be the source of truth, I think there's benefits to introducing a new source of truth, an external source of truth that isn't part of your code base. I'm going to do another list. Benefits of having an external API like this, even if you change your tech stacks or if you have microservices and some of them are built using different technologies, you're able to have a single definition for your API surface. If you have things like mobile apps or other technologies, obviously it can work well with things like that. You're less dependent on the library, so when you have these generous open source maintainers giving their time, you're obviously at the mercy of them deciding not to update things or the cadence at which they fix bugs and so forth. And also, you get a lot of integration with a larger ecosystem of tools when you have a purpose-built API definition, let's call it. And one of the biggest benefits that I like about this system is it lets you collaborate on the API definition without writing code. So you can have a document that defines your API, and you can use that as a starting point for a conversation. You can have a pull request with just that definition without, first of all, either the back-end or front-end people feeling like they own it, or without you being dependent on either of them to do a piece of work first. You can start from this definition and you can work on that before you start actually cutting code, which I think is really, really cool. So the most common way to do this and the way that we do it is OpenAPI, very famous, very common, very well-established spec. It's like a super dry document if you haven't seen it. It's like one of those RFCs where they write must not, should not, all of the all caps language that you love to read. It used to be called Swagger, which I think is a way more cool name, but I can understand why they named it the OpenAPI. Is very more literal, but more useful possibly. But the big downside of the name is that it's very, very similar to OpenAI, which if you're like me and you work with both of these technologies, you'll be like typoing one of these for the other like the whole time you're using them. And this document looks a bit like this. So you can use different formats. If you're a Rails developer, you're probably very comfortable with YAML. So we use YAML. Very familiar perhaps. And this is like a definition of your API in a machine-readable kind of contractual way. And so I'll just quickly break down the different parts of this. This is like one route in your Rails, your app, I guess. And so this is the path. You've got some information here about what query parameters or path parameters this particular endpoint can take. You've got the HTTP verb that goes along with it. This is a post endpoint. You give it a name, and the beauty of this is the front-end developers are only going to have to know that name and really none of the other stuff. They won't care what the route is or any of that stuff. That's an implementation detail for the back-end people to worry about. So you give it a sensible name that helps people understand and identify it later. And then for each of the different kinds of responses that it can give back, you've got a block like this. This is HTTP 200. You have information about the schema, including the types of the data. And this is a very simple example. You can go into lots of detail with different union types and different things that can happen. But just to give a very simple illustration. And if you want to link off to other files, you can compose things very well. So it's great for reusing different bits of your code and trying to maintain your API in a dry way. And finally, like the input, the request body. Similarly, you have types for that, so you know exactly what's coming into it, and you can enforce that in your code. And so this lets the API exist like independent of the implementation. And because OpenAPI is like a really popular standard that heaps of people use, not just for Ruby and TypeScript, but for every language you can think of, there's heaps of tooling around it, which makes it really easy to use. So obvious example is there's heaps of tools that let you take that YAML file and turn it into API docs. So this is Redoc. There's dozens of tools like this. You'll end up with a website like this. You've probably seen heaps of these. It just takes your API information. You can put in examples. You can put in the types and the descriptions and things. Makes it a nice human-readable format. And you kind of get this for free just by having that YAML file exist. The next kind of tool you might want to use is like a more interactive way to build that document. If you don't want to edit the YAML file yourself, there's tools like Stoplight, which I've used a bit, which let you edit the YAML file in a more visual way. You can see a list of things. You can click toggles in your UI to change different elements. You can copy and paste endpoints more safely. So yeah, you get lots of tools like this. There's linting and other like developer experience type tools. Spectral is the linter that we use for OpenAPI, so you can make sure that the format of the file, apart from being syntactically correct, also matches like the style definitions your organization has for how it should work. These are really cool. And one more option is you can also, if you don't want to write the YAML yourself, which I totally understand, there's high-level languages that you can write and start as a starting point and compile into OpenAPI definitions. So I think this is like a meta one, maybe TypeSpec. Sort of like a high-level language that compiles down into OpenAPI, which is a bit nicer to work with and a bit easier to reuse things. So lots of options for how you work with it, but very valuable to have that sort of common intermediary point of the OpenAPI schema. So how we use that is basically we take that YAML file that we wrote and we want to turn it into two things, right? We want TypeScript types from it and we want Ruby. Well, Ruby doesn't really have types exactly. It can, but we don't use Ruby types. So we need some other way to verify it on the back end and make sure everything actually lines up. And I'll talk about that in a sec, but let's talk about TypeScript first because that's much more straightforward. We use a brilliant package for this called OpenAPI codegen TypeScript. This basically takes that YAML file and it spits out TypeScript types. Not only that, but it can build React query components. It can build the functions that you actually use to call the API in a type-safe way. So you give it a little config. Don't try to read this. The detail's not important, but you give it an input file, a YAML file. You give it an output folder, and we're doing two things with it. We're generating types from our schema, which will be like the components and the other things in your OpenAPI schema, and we're generating React query components, which is like hooks that you can have to use the API directly without having to know any of this stuff. Once you've done all of this work, the developer surface is really, really simple. And the types you might get from this that it generates look something like this. So if you've got like an enum type in your OpenAPI schema, it's turned that into a TypeScript string union, which is really nice. It knows about which fields are nullable and not. It knows about the different formats and things. Things like UUIDs that don't have a TypeScript type. I guess you could construct one with the string interpolation types, but it just uses a JSDoc annotation for those kinds of things. And it keeps the naming consistent across your OpenAPI file and across your TypeScript code base, which is pretty nice. And then it also gives you a function which uses those types and calls you bring your own fetching library of choice, Axios or Fetch or whatever you want to do. It gives you a function that has a sensible name and just calls that API using all of the types and stuff that you've got set up. You can see it has the path encoded in it here and the HTTP verb and the other bits and pieces. So you'll call this function and this will actually call the API and give you the data back in the correct type. And then it goes one level higher than that, one level of abstraction higher than that, and gives you a React query hook. And so this just kind of wraps, this is a hook for the same function that just gives you a use query and it generates the query key for you, does all of the React query things you'd need to do to set it up normally. So at the end of the day, I don't have a picture of it. At the end of the day, all the developers are going to have to do on the front end is call that hook and use it. And so you run this code generator, it spits out this directory full of files, which you check into your code base. You don't have to think too much about them after that. Like it is extra code you have to maintain, but you're not really editing it directly. You're kind of just generating it, and you can do a once over in your pull request, but you don't have to carefully think about it too hard. And if you haven't heard of React Query, because I did just sort of gloss over that element of it, I'll briefly mention it. This is probably one of my favorite libraries I've used in the last few years for doing front-end state management, kind of the lifecycle management for calling APIs. You can do lots of different things with it, but in terms of using it for your API lifecycle, it is a real time saver, and I strongly urge you to investigate it if you haven't already. It just lets you remove a lot of client-side management. When I came into the legacy app that I'm responsible for at the moment, it was using Redux to do a lot of the API calls. And so you have these two components, and they both want to call the same API, but you don't want to call the API twice. You just want to call it once, and they both want access to the data. And like the Redux solution to that is you introduce a store, and then one of the components is going to dispatch a Redux dunk, and it's going to create an action which is going to kick off the API. Data's going to come back, it's going to put it in the store. You're going to get it from a selector. Like it's a lot, and you're writing all that code. That's not generated. That's like code you have to write each time you want to do a new one of these. It's quite painful. And obviously there's better ways of doing that now, but React Query really just removes all of that work. It handles all of the caching and the deduplication, and if the API fails, it will retry it with an exponential backoff. All of the stuff you want to build, but you don't have time when you do it by hand. It just solves that whole category of problems. So I can't recommend that highly enough if you haven't used it. So at the end of the day, all the front-end developer is going to have to do is call this one hook. That's going to call the API. They're going to get this data back, and it's going to have the exact right types at the right time, and they can just use it without thinking too hard, which is my favorite, a mechanism or a metric I use often for my success in my coding. So the TypeScript types are pretty straightforward. Ruby, you have to approach a little bit differently. Obviously, like I said, there are types for Ruby. So there's a project called Sorbet, very popular. I think Shopify maybe started it. It does add types to Ruby, and it gives you a compile step, and it lets you annotate them. It's a little bit clunky, but it does the job. And there definitely are ways you can take your OpenAPI schema and turn it into sorbet type. So this gem schema sorbet is the first one I found on Google. Haven't used it, but definitely that's a path you could go down. But I found the Ruby engineers that I work with tend to not necessarily be compile step type oriented people. And the code bases I worked on tend to not have sorbet, and so you'd have to introduce it, and you can adopt it incrementally, but it is quite a big task. And so what I've experienced is that the Ruby culture around a problem like this is more solved by unit testing or some kind of testing rather than trying to add types into your app. And so that's the way we approached it. This is a gem OpenAPI first that lets you add a rack middleware into your Rails app that will take that same YAML file that we wrote, and it will look up the path for on when a request is happening. It knows the request details. So it will look up the path in your YAML file, and it will compare the schema of what's come in to what the YAML file says it should be. And if it doesn't work, it will throw an exception. So in dev, you just get like these kind of screenshot of my dev tools, but you can see if the types were wrong in the response or the request, you'd get a runtime error at that point. And so it's quite a good developer experience. You just know straight away when stuff's broken and you can fix it. If you want to then take that and test it, all you need to do is write some test that hits your API. So this is a real test I have where it's literally just doing an API call and then expecting it to be successful. And the middleware is going to run when that happens, and if the types don't align at that time, it will crash and the test will fail. So you don't need to add anything to your tests, just the fact you have a test is enough to validate that the schema matches. And you can obviously test other stuff. I don't recommend you only have that one test. You probably should write other tests that test your business logic and things other than your schema, but you don't have to if you don't want to. And we don't run that on prod. You could fail prod requests if the schema was wrong. We find that a bit heavy-handed. So the middle ground we have there is you can log stuff. We use Datadog, so every time a validation fails in prod, we don't do anything different in the request, but we'll log it, and we can look at patterns and things there and see if anything needs to change. So that's how we do it. It works pretty well. Obviously, that's a whirlwind tour, but I understand we're under some time pressure. It had a lot of advantages of how we used to do things, certainly. A lot less boilerplate. It's much easier to work with, and the certainty is much higher. So in particular, that lets you refactor code with much more confidence because you know how the types are used, and you know that they, with quite a degree of certainty, reflect reality. So you can be confident when you're making changes on the front end. We do a lot of big sweeping refactors now that would have been very scary to do before. I really like the aspect of having the single YAML file that we can collaborate on. I think that's an important part of it. You can generate some docs out of it. We don't do that. It could be cool. I think it's more important if you have an API that the more people that are going to use the API, the more important and valuable the docs are. And very importantly, you can adopt this incrementally. You don't have to map out your whole API surface in that YAML file. You can do one endpoint, get all the benefits on that one endpoint, and just keep adding to that over time if you find it valuable, which I think is really useful. I will just quickly mention, I'm not going to talk about GraphQL, but I feel like someone will ask me about this if I don't say it. GraphQL does exist, and it does solve a somewhat similar class of problems with a very different set of trade-offs and pros and cons. So it's another option. This talk is not about GraphQL, but I do like it and I have used it. So yeah, that's it. That's all I wanted to say. Just a few takeaways, which are the things I've learned from this exercise, apart from the specifics about the code, I think are, first of all, that the standards are great. Like, I leverage standards a lot more than I used to. Anytime you can use something that's like not tied to a specific person's implementation, but there's a standard behind it that you know if they stop maintaining it, you could go, someone else would solve the same problem. Or if I wanted to use Haskell, now I can generate Haskell because someone else will have implemented the same standard. Really good. I was also very suspicious about code generation before doing this project. I don't like having a bunch of code that I didn't write checked into my code base. It feels like, it just feels like something you shouldn't have to do. You should be able to generate it at runtime or whatever. But actually, it's great, and I love it. And I committed it, and now I don't think about it anymore. And just really saves you a lot of typing. Obviously, it's ideal to not do it, but if it solves the problem you have, I think it's definitely worth it. Yeah, this is not something I learned, I guess, but something that I feel strongly that if it's possible to catch errors at build time, it's much better, especially if it means your customer's not finding those issues. But even if it's you clicking around in dev, if something can be done in a static compile step, that's awesome. This is probably obvious, but took me a while to figure out that most of the time, actually, the hard part of building any kind of software system is the communication part, the agreeing what to build, the agreeing how to build it, and then splitting up the work and deciding how to do things, and talking about code is often much harder and much more time consuming than the actual code itself. And so I think this is something that helps with that, having that document, having it accessible to even non-technical people who can understand, or people who know what an API is, but maybe don't want to get into your code. It's a real benefit in that way. And I'd also, I think this has really taught me that even if you are the only one who uses your API, you and your team, even if you're never planning for it to be public, first of all, even if you're planning for that, all of the ethical hackers who are pen testing your system will still be using it. So you might as well make it nice for them. But even if you don't, I think it's worth making it nice for yourself. And even if it feels like a lot of work up front, it actually pays off. The longer you work on something, the more that time pays off. So yeah, I think that's everything. Yes, that's it. Thank you.
I think we've probably got some time for questions.
Oh yeah, give me some.
What was the name of that query thing again? That looked like it would solve some problems that we're having at the moment.
TanStack query is the library. Yeah, it used to be called React query, but now it does Vue and other libraries, so they had to rename it. TanStack query. Very good. You could do a whole talk on that for sure.
Do you do CI cross-checks of kind of generated code against front-end back-end?
Yeah, we do. So on CI, we run the code generation again and just check that it matches exactly what's in code. And so you can't merge anything into master where the code generation hasn't been run. We don't automatically run it, but we just enforce that you have run it before you merge. Yeah.
How do you end up writing the YAML file? Because that's a lot of lines of code, right?
Yeah. We investigated a lot of different tooling for doing it, like the stoplight one that I showed briefly. I used that for a long time, but actually I'm way more productive just editing the YAML file by hand. That's what I do now. And like usually you'll find a similar API and copy it as a starting point, so you don't have to do all of the indentation yourself. But also Copilot can just like auto-generate it based on context. So
Yeah.
it's pretty good for that.